All right, so today we're diving into something pretty interesting.
Yeah.
It's a messaging app called Smoke.
Okay.
Have you ever tried to send a message, but your internet connection
Yeah.
is totally unreliable? Like,
All the time.
it's just awful.
Absolutely.
That's the kind of problem Smoke is designed to solve.
So it's like for those situations where you're like out in the field or maybe like,
Yeah.
traveling or something.
Exactly.
That's cool.
It goes beyond just secure messaging.
Uh-huh.
It's built to work, even when you don't have a good connection or any connection at all.
That's really interesting because a lot of apps, they kind of rely on that constant connection to
Right.
work properly.
And we're going straight to the source for this one,
Okay.
the smoke.pdf documentation.
Right.
We're going to break down how it works, what makes it so special, and why you might choose Smoke over your regular messaging app.
I'm excited to dig into this.
Yeah, me too.
Yeah.
So first things first, what exactly is Smoke?
So from what I've gathered from the documentation, it's an Android app
Okay.
for both group and individual communication.
Got it.
Plus, it can handle file sharing.
Nice. So it's like an all-in-one.
Yeah, it's all within a single app, which is
Yeah.
really convenient.
That's great. You don't have to be switching between apps.
Exactly. Keeps things nice and simple.
Yeah, I like that.
And I also noticed that it's open source,
Oh, yeah, that's a big one.
with the code available on GitHub, which is
Always a good sign.
always a good sign for transparency.
Yeah, especially when we're talking about security.
Absolutely. Open source means anyone can look at the code and see exactly how it works, which really helps build trust.
Mm-hmm. And speaking of security, that seems to be Smoke's main focus.
Yeah, they really emphasize that in the documentation.
Yeah, there's a lot of detail about encryption and authentication.
It's not just like a surface level thing. They're using some really serious techniques.
Like what?
Well, they mentioned things like AES 256, SHA 512.
Wow, those are some big names in cryptography.
Exactly. And get this, they even use McEliece,
McEliece. Okay.
which is specifically designed to withstand attacks from quantum computers.
Quantum computers. Whoa, hold on. I'm not a computer scientist.
Yeah.
How does that affect me?
So think of it this way. Even if someone got their hands on your encryption keys, years down the line, when quantum computers become more common,
Uh-huh.
they still wouldn't be able to decrypt your past conversations.
That's pretty amazing.
It's called forward secrecy.
Okay.
Your messages stay secure even if the technology changes drastically.
So they're really thinking ahead.
Absolutely.
Wow. What other security features stand out to you?
Well, they use digital signatures, which are like tamper-proof seals for your messages.
Okay.
You can choose whether to use them for regular messages, but they're mandatory for key exchanges.
Because an extra layer of security.
Exactly.
So even if you're in a place with a bad internet connection,
Right.
your messages are still going to be protected.
They're locked down tight.
But how does Smoke actually deal with those network disruptions?
That's where their offline first design comes in. Smoke uses an asynchronous communication model.
Asynchronous.
Yeah, so it doesn't need a constant connection to send or receive messages.
So kind of like email in a way.
Yeah, exactly. You can write a message offline and it'll send when you're back online.
Okay.
But Smoke takes it a step further with its companion app, SmokeStack.
Right. SmokeStack. So that's like a separate app.
It is,
Yeah.
and it acts as a mobile server for storing and retrieving messages.
So walk me through that. How does that work?
Imagine it like a secure Dropbox for your messages.
Okay.
You send a message to a SmokeStack,
Mhm.
and even if the recipient is offline, their Smoke app will grab that message from the SmokeStack as soon as they connect.
So the SmokeStack is like holding on to it?
Exactly. It's like the middleman.
Gotcha. That's pretty clever.
Yeah.
And then they also mentioned something called ozone addresses.
Right.
What are those all about?
Ozone addresses are unique identifiers that are used to retrieve messages from your SmokeStack.
Okay.
It's kind of like your personal address in the Smoke world.
So it tells SmokeStack where to deliver the messages.
Exactly.
How does SmokeStack know where to send those messages in the first place?
Ah, that's where things get really interesting.
Okay.
They use something called cryptographic discovery.
Cryptographic discovery. It sounds very mysterious.
It does, right?
So what's going on there?
Basically, SmokeStack can figure out where to send your messages using limited and non-private information from your device.
So you don't have to constantly broadcast your location or your IP address.
Exactly. It's
Yeah.
all done in a way that protects your privacy.
That's a relief.
Right?
It's good to know that they're thinking about those things.
Yeah, they've really managed to balance privacy and efficient communication, even in really tough conditions.
It sounds like they've really thought of everything.
Yeah, the documentation is really thorough.
There are a couple other cool features that I want to touch on.
Okay.
One of them is the calling feature.
Oh, yeah.
Now, it sounds pretty straightforward,
Uh-huh.
but there's actually more to it than meets the eye,
Yeah.
right?
Right. So on the surface, it lets you securely exchange private key material with another Smoke user.
Okay.
But what's interesting is that it's presented as a more private alternative to simply swapping phone numbers.
Oh, I see. So it's like a super secure way to start a conversation.
Exactly, without revealing any personal information right off the bat.
That makes sense.
It's perfect for people who really prioritize anonymity and privacy.
And then there's Steam,
Yes.
which is Smoke's file sharing system.
Right.
And again, it's not just your average file transfer tool, is it?
No, not at all. Steam is designed to work even with those unstable connections that we've been talking about.
So it can handle the disruptions.
Exactly. And it can even stream files while they're downloading.
Oh, wow.
So you can start accessing content before the transfer's even finished.
That is really handy, especially if you're trying to share large files over a slow connection.
Absolutely. It's perfect for those situations.
It's like they really understand the challenges that people face in those environments.
Yeah, they've really put a lot of thought into it.
Now, there's one section in the documentation that really caught my eye.
Okay, what's that?
It's called corrupted database values.
Interesting.
Now, most software tries to hide errors from the user.
Right, they don't want you to see the messy stuff behind the scenes.
Yeah, but Smoke seems to take a different approach.
Oh, so they're more transparent?
Yeah, if the data gets messed up for whatever reason,
Uh-huh.
it shows you the problem instead of trying to sweep it under the rug.
I like that. It builds trust.
Exactly. It's not just about security, it's about giving the user more control.
You're not left wondering if something went wrong.
Right. You know exactly what's going on.
It's refreshing to see that level of transparency.
And then there's a whole section on congestion control.
Congestion control. Now, you don't usually see that in a messaging app.
No, you don't.
What's that about?
It shows how much emphasis they place on performance,
Okay.
even under unpredictable network conditions.
Makes sense.
It has its own system for managing data flow,
Mm-hmm.
making sure your messages get through.
Even when the network is totally jammed.
Exactly.
Wow, they really have thought of everything.
It seems like it.
So it's not just secure and private, but it's also efficient and reliable.
Exactly.
Yeah.
So to sum things up, who do you think Smoke is really? FOR.
Well, if you connect all the dots, it seems like it's perfect for anyone who values privacy.
Mm-hmm.
And RB needs reliable communication in places with unreliable internet.
Right.
So we're talking about journalists in conflict zones, aid workers in disaster areas, or even just people who live in areas with spotty internet service.
I can definitely see the appeal.
Yeah.
For anyone who really likes to tinker with technology and appreciates the level of detail in the security features.
Absolutely. It's an app that rewards those who like to dig a little deeper.
For sure. So if you're looking for a messaging app that's built for a world where the internet isn't always perfect,
Yeah.
Smoke might be just what you need.
It definitely seems like a powerful tool for anyone who takes communication security and reliability seriously.
Absolutely. All right, so we've covered a lot of ground here, but there's still more to explore.
There always is.
We'll be back in the next part of this deep dive to unravel even more of the mysteries of Smoke.
Sounds good. I'm looking forward to it.
Me too.
Yeah,
Yeah.
it really is a fascinating example of combining cutting-edge technology with real-world solutions.
Absolutely.
Yeah.
It's not just theory, it's designed to handle the, messy realities of communication.
Exactly.
Speaking of which, one thing that I'm still a little bit curious about is this Smoke identities concept.
Oh, yeah.
The documentation makes it sound really important,
Mm-hmm.
but I'm not totally clear on what it actually means for the user.
Right. It raises some interesting questions about how Smoke balances user privacy with the need to identify and connect people.
Yeah, like how does that work?
So Smoke identities are actually generated using something called the CipHash algorithm.
CipHash. Okay, remind me, what exactly is a CipHash again?
Well, it's a specific kind of cryptographic hash function
Okay.
that's known for being both fast and secure. Basically, it takes an input,
Yeah.
in this case, your public encryption and signature keys,
Okay.
and turns them into a unique 128-bit identifier.
Right.
And that identifier is your Smoke identity.
So it's kind of like a digital fingerprint for your keys.
Yeah, you could think of it that way,
Okay.
but much shorter and easier to work with.
Gotcha. So how does that actually help connect users then?
Well, instead of sharing your full public keys,
Right.
which could be quite long,
Yeah.
you just share your Smoke identity. It's
Okay.
much more efficient.
That makes sense. But what about the possibility of two users ending up with the same Smoke identity?
Ah, that's a good question. And The documentation acknowledges that it is possible.
Okay.
Since there's a limited number of possible outputs for the SciFash function, collisions can happen.
So they're not trying to hide that.
No, they're very upfront about it.
Okay. But how do they deal with it then?
Well, the documentation doesn't get into specifics.
Okay.
But it's safe to assume that they have ways to detect and handle these collisions gracefully.
So maybe some kind of backup identifier or a process for resolving conflicts.
Exactly. It shows that the developers thought about these edge cases and likely built in safeguards to prevent problems.
Okay, so smoke identities are how users connect behind the scenes.
Right.
But what about those of us who prefer something a little more user-friendly, like a regular contact list?
Yeah.
That's where smoke aliases come in, right?
You got smoke aliases are basically human rootable identifiers that are easy to share and remember.
Okay.
Similar to email addresses.
So instead of remembering a long string of random characters,
Right.
you could just give someone your smoke alias.
Exactly.
Something like Jane Doe at Secure Chat or something.
Yeah, much easier on the eyes.
Way easier.
And behind the scenes, Smoke uses that same SciFash algorithm to convert your alias into a smoke identity.
So it makes things simpler for the user without compromising security.
Exactly. It's a very elegant solution.
Now let's circle back to the companion app SmokeStack.
Okay.
We touched on it earlier.
Yeah.
But I'm curious to know a little bit more about the nuts and bolts of how it all works.
So the cool thing about SmokeStack is that it plays two really important roles.
Okay.
It's not just a storage and retrieval system for messages. It also acts as a private public key server.
Oh, wow. So it's like the central hub for everything smoke related.
In a way, yes. It allows users to access messages offline and provides a secure platform for exchanging public keys.
But how does it protect those keys?
Good question, because we've talked about how important security is for Smoke.
Yeah.
So I imagine SmokeStack has some pretty robust security measures in place.
Absolutely. The documentation talks about something called private servers within SmokeStack.
Wait, private servers within SmokeStack?
Yes.
So like a server within a server?
Basically,
I'm intrigued.
these private servers are designed to only allow connections from Smoke clients that have been authenticated.
Okay.
And the authentication process itself is pretty fascinating. Oh yeah, how did that work?
It uses a multi-step challenge response system that relies on digital signatures and random data exchanges.
So it's not just a simple password.
No, it's much more sophisticated than that.
They're really making sure that only authorized devices can connect.
Exactly. And there's more. SmokeStack also uses that cryptographic discovery feature that we talked about earlier to help route messages to the right people, even if their devices are constantly moving between networks.
So it's like a dynamic address book that's constantly updating itself?
Yeah, using those encrypted clues from the devices.
It's impressive how they've packed so much functionality into what's essentially a messaging app.
It really is like a whole ecosystem built around secure communication.
Speaking of functionality, there's one feature we haven't touched on yet that seems particularly unique.
What's that?
It's called smoke pipes.
Ah, yes. Smoke pipes. This is where Smoke really starts to go beyond a typical messaging app.
Yeah, the documentation describes it as a way to transfer data to devices that don't even have Smoke installed.
That's right. It's almost like a secure file transfer protocol built right into the messaging app.
So it's like built-in file sharing.
Exactly. And there are two types of smoke pipes.
Okay.
Dull simple steams and vivid simple steams.
Dull simple steams and vivid simple steams. Those are some interesting names.
Yeah, they definitely stand out.
What's the difference between the two?
So dull simple steams use plain TCP connections.
Right.
While vivid simple steams use TLS encryption for security.
So it's a choice between speed and security depending on how sensitive the data is.
Exactly. And what's really cool is that smoke pipes allow you to stream data in real time.
So theoretically, you could use Smoke to stream video or audio to another device, even if it doesn't have Smoke installed.
That's right. It opens up a whole world of possibilities beyond just text messaging.
It's like a Swiss Army knife for secure communication.
I like that analogy.
But with all this talk of advanced features and complex protocols, how does Smoke actually perform in the real world?
Right, because that's what really matters at the end of the day.
Exactly.
Yeah.
And the documentation has a section on performance considerations,
Okay.
which suggests they've put a lot of thought into this.
Yeah, this is where you really see the developers' attention to detail shine through.
Yeah, so what kind of techniques are they using?
Well, they rely heavily on multi-threading.
Multi-threading, okay.
Which means Breaking down tasks into smaller chunks that can run at the same time.
So instead of doing everything one step at a time,
Right.
Smoke can handle multiple tasks simultaneously.
Exactly, which makes it feel much faster.
That makes sense. They've also optimized the way data is accessed, how the app communicates over the network,
Right.
and even how the user interface updates.
It's all about making smart design choices to get the most out of the available resources.
And that same focus on performance extends to SmokeStack as well.
Yeah, they haven't neglected the companion app.
They've implemented a lot of optimizations to make sure retrieving messages and exchanging keys is as efficient as possible.
So everything runs smoothly even when you're dealing with those unreliable connections.
It's remarkable how much thought and care they've put into making Smoke not just secure and private,
Right.
but also fast and user-friendly.
Yeah, it's a really impressive feat of engineering.
There's one more thing I want to explore before we wrap up,
Okay.
and that's the app's commitment to future-proofing.
Future-proofing. Interesting.
The documentation has a section called Future-Proofing Software
Ah.
that hints at some interesting things they're doing.
So they're not just thinking about current threats, but also anticipating future challenges.
Exactly. One thing they specifically mention is moving away from commonly used encryption modes like CBC and CTR.
CBC and CTR.
Okay.
Because of potential vulnerabilities.
That's a pretty big deal because those are widely used.
They are.
So it seems like the Smoke developers are really trying to stay ahead of the curve.
Yeah, but what does that mean for users? Well, it's not entirely clear from the documentation,
Okay.
but it seems likely that Smoke is designed to be flexible and adaptable.
So they can upgrade the encryption without having to completely redesign the app?
Exactly. It shows a forward-thinking approach to security.
So they're building a messaging app that's not just secure today,
Right.
but will stay secure in the future.
Even as the security landscape changes.
Right. And they also talk about the importance of using interchangeable cipher and hash algorithms
Yeah, so they're making Smoke as adaptable as possible.
to keep up with the ever-changing world of cryptography.
Exactly. They're even looking ahead to the eventual adoption of quantum-resistant algorithms.
Quantum computers again.
It seems like they're always lurking on the horizon.
They do.
It's definitely something that any serious security project needs to take into account.
And Smoke seems to be taking it very seriously.
Absolutely. It's reassuring to see a team that's so dedicated to staying ahead of the curve.
And building something that's truly designed for the long haul.
Yeah, it sets a high bar for secure communication in a world that's becoming increasingly reliant on being connected.
Now, you mentioned quantum-resistant algorithms.
Yeah.
What does that even mean in practical terms?
So quantum computers are still in their early stages,
Okay.
but they have the potential to break many of the encryption methods that we use today.
Oh, wow.
So while it's not an immediate threat,
Mm-hmm.
it's definitely something we need to start thinking about now.
To make sure our data stays secure in the future.
Exactly.
So Smoke is already incorporating these quantum-resistant algorithms.
That's right. They're not waiting for the problem to become a crisis.
I
They're
think
being proactive.
it's a sign of their long-term commitment to security.
Absolutely.
It's interesting how they've managed to balance this forward-thinking approach
Right.
with a focus on practicality and usability.
It's not just about theoretical security.
Yeah.
It's about making a tool that people can actually use in their daily lives.
Right, even in challenging circumstances.
Okay.
Speaking of practical considerations,
Okay.
the documentation mentions the importance of accurate timekeeping for Smoke to function properly.
Oh, that's interesting. Why is that so important?
Speaking of practical considerations, the documentation mentions the importance of accurate timekeeping for Smoke to function properly.
Well,
Why is
yeah.
that so important?
Well, time is kind of like a hidden ingredient in a lot of Smoke's security stuff, especially when it comes to verifying messages and making sure those key exchanges go smoothly.
Uh-huh.
Like if your device's clock is way off, it can really mess things up. Messages might get rejected, keys might not match up.
Yeah, that makes sense. So it's not just a convenience thing. It's about security.
Exactly. It's about making sure the whole system works the way it's supposed to. And to avoid those kind of problems, Smoke has a built-in way to check your device's time against a reliable source.
Oh, okay.
Yeah, so if there's a big difference, it'll let you know so you can fix it.
So it's like a safety net.
Yeah, exactly. Another example of how they've really thought things through.
This has been a fascinating deep dive, exploring the inner workings of Smoke.
It really has.
We've covered so much ground, from its unique offline-first design to its robust security features and those innovative communication protocols.
It's a testament to what open source software can achieve.
But, as with any deep dive, we've only scratched the surface.
There's always more to discover.
There's a whole lot more in that documentation. It's packed with technical details and insights.
For those who want to go deeper.
So for our listeners who are feeling adventurous, I definitely recommend checking out the full smoke.pdf documentation.
It's a great read for anyone interested in the future of secure and resilient communication.
Absolutely. And if there's anything specific about Smoke that really caught your attention, let us know. Maybe we'll dedicate a whole episode to unraveling it. But until then, stay curious, stay secure, and keep those messages flowing, even when the internet's not cooperating.